Welcome to a new video from FC Mastery Path. This is Mo, and I'm glad to be your presenter today. In today's video, I'm going to be showing you how you can fine-tune your own model using Unsloth and add some reasoning capabilities on your fine-tuned model of your choice using a custom dataset. And then we're going to be showcasing how you can use your own fine-tuned model of choice on Open WebUI, which is a front end, to test your model and see how good or bad it really is. We're going to be splitting today's video into 7 steps or 7 parts. We're going to be starting with setting up the coding environment and installing the necessary requirements for our project, and then we're going to be moving towards importing the necessary libraries and downloading the large language model of choice. Then we're going to be jumping to the data preparation and building the reward functions for the RLHF fine-tuning. The fourth step, or the fourth part, is going to be training the model under the GRPO trainer and showcasing how this works. And then we're going to be testing and saving the fine-tuned model, where we're going to be merging the LoRA adapters with the original model to create one merged model, which can then be converted to GGUF format to be used on Ollama Open WebUI or any other initiative. The sixth step or sixth part is another alternative for LoRA adapters merging with the original models if the Unsloth sub-libraries or dependencies did not work out for you correctly. And the last step would be the deployment of the fine-tuned model on Ollama and Open WebUI. Before we jump straight in the different parts of this video, I just want to clarify that I'm going to be undertaking everything on Linux because of the different dependencies that are only available for Linux. And I'm using a Core i9 12900KF processor with 64 GB of DDR5 memory and a GPU Nvidia RTX 3090 with 24 GB of VRAM. The dataset that we're going to be using in today's video is custom datasets, and everything is done locally without the use of any cloud computing options. And now, without further ado, let's get started. All the code is provided in today's video is presented on my GitHub repository. One of the repositories that I've created is called Unsloth LLM Fine-Tuning, which you can access by going to github.com/moashore93/Unsloth LLM Fine-Tuning. In here, I'm exploring 2 methods of fine-tuning. The first of them is using conversational chat templates, and I've prepared a full README file about this, and also the actual Jupyter notebook, which you can explore in your time. And also, I have created a folder for the GRPO fine-tuning, which is basically the technology behind DeepSeek and adding reasoning to your model. And I've crafted a very detailed Jupyter notebook, which you can open in your time. And that's basically the Jupyter notebook that we're going to be discussing in today's video. And you can find all the explanation and the code in there. So starting with the first part of today's video, which is setting up the coding environment and installing any required dependencies. First thing is we need an integrated development environment. My integrated development environment of choice is VS Code. You can download it by going to code.visualstudio.com/download. It's available for different operating systems. We're going to be using the .dep because I'm using Ubuntu. I'm using Pop! OS, which is a variant of Ubuntu. Download it and install it. And then we need a programming language. Normally you would go to python.org/downloads if you're on Windows or Mac. In here, it's a bit different on Linux because we need a specific variant of the Python programming language. First of all, I have added DidSnakes PPA repository, and I updated all of the packages that I do have on the system by using the sudo apps, and you're going to be asked to enter your password because sudo gives root rights. And then I installed Python 3.11, and I made sure that I have the dev option or variant of Python because I faced one of them problems when I was compiling the code at the end with Llama.cpp and PyTorch, that there was a failure to compile. So Python developer, or the developer variant of Python, was necessary for my task. And then because I had multiple Python versions on my machine, 3.10 and 3.11, I had to make 3.11 as the prominent or the current version on my system by following these 2 lines of code through the alternatives method. And then I needed to install and make sure that virtual environment as a library is existing on my system. So I installed pip install virtual environment, and I created the virtual environment of choice, which is unsloth_env_march25. You can change the name however you see fit. And then I activated it through the source method. So source and then the name of the environment /bin/activate. And you can see here, so unsloth_env_march25. Unsloth team, they suggest that the best way to install Unsloth on Linux is through pip install Unsloth, which I followed, and I also installed VLLM for fast inferencing as advised by Unsloth. Unsloth is now available on Linux and Windows. However, if you are targeting fast inferencing using VLLM is only available on Linux, so keep that in mind. And also Unsloth is based on CUDA architecture, so it will not run on CPU. If you are planning to do fine tuning on CPU, Unsloth is not your way to go. It's going to be embedded and supported in the near future. And one last thing to install is CMake. I faced a problem while I was converting the model from the safe tensors format to GGUF with Llama.cpp, so I had to install the CMake using the sudo apt command and make sure that you enter your password when prompted. The next piece of the puzzle is the Nvidia CUDA toolkit or Nvidia CUDA compiler. I installed the version of 12.4. Installing a version of Nvidia CUDA toolkit is fairly simple. You can go to the link provided in my Jupyter notebook, or you can search online Nvidia toolkit 12.4 for Ubuntu, and then you pick up the first link. You choose whether it's Windows or Linux. For our video today, it's going to be Linux. And for me, I'm using an Intel processor, so it's x86. The nearest distribution is Ubuntu. And if you're using Windows subsystem for Linux, you can also download the CUDA toolkit from here. And my version is 22.04, and I use the dep. Basically, it's just going to be a game of copying and pasting these lines of code into your terminal, which I'm showing here. So copy and paste these lines of code into your terminal to make sure that you're installing 12.4. Why specifically 12.4? It's because the PyTorch version, which is downloaded with Unsloth, when you do the pip install Unsloth, it supports the 12.4. I had previously two versions of CUDA, 12.4 and 12.6, and I was facing all sorts of errors. And here comes an issue of the compatibility between the CUDA toolkit and the PyTorch. I had two versions of CUDA toolkit installed, 12.4 and 12.6, and I was facing all sorts of problems. I had to make 12.4 as the main version and make all of them links to it. So the first thing that I had to do is list everything that I have which contains the word CUDA. So in my case, it's now, because I've already done it's 12.4 only, but previously I had two versions, 12.4 and 12.6, and then you can here check which version is installed, which is 12.4, and that's the location of it. What I have done is I have added these lines at the end of the bash file, which you can open using nano editor. So you can type in nano and then hyphen and then the .bash file. That's going to open the bash file. You can go to the very end of it and add these lines, which I've added here. And then what you do is press Ctrl O and then enter and then Ctrl X, so that you save everything in the nano. So Ctrl O, enter, and then Ctrl X. The bash file now is done and dusted, or is saved. And then we need to verify which version is installed again. If you still find a couple of them, so previously I was still facing that here, the build CUDA is 12.6. I had to build a symbolic link for everything that has CUDA to be 12.4 using these two lines of code. And then I was facing some other problems concerning the compilation of PyTorch, and I had to install some of them essentials, including the build essentials and the GCC multilib and the G++ multilib. I installed the Nvidia CUDA dev developer option or developer variant, and I had to declare some of the variables before jumping in the training itself. There are two remaining aspects that we need to install before we jump in. So we need to install Ollama. Ollama provides the option to the end user to chat with models locally on one's machine. You can explore Ollama by going to Ollama.com, and Ollama is available for Mac, Linux, and Windows. The installation for Windows and Mac is through the download, but the installation for Linux is through this line of code, where it's curl and then the link for Ollama install. If you want to download some models locally on your machine, that's going to be quite easy. It's through Ollama and then pull and then the name of the model of your choice. You can get to know the models of choice by going to Ollama.com and then go to the models tab, and you'll find all sorts of models. You can click on any one of them and then you can put Ollama on and the name of the model, or Ollama pull and the name of the model. You can also list the names of the models that you have downloaded after you download a couple of them by going to Ollama list, and in here I have a wide variety of the models that I have added to Ollama. The majority of them are my fine-tuned models, which I have clarified in other videos on this channel. The last piece of the puzzle is having Open WebUI, which gives you an interface like ChatGPT to chat with your models, and it's linked to the API of Ollama locally on our machine through the local host 11434, and it can also be linked to a wide variety of them cloud-based models like OpenAI models or Anthropic models and the likes through different pipelines. You can install Open WebUI now quite easily through pip install Open WebUI, pip install Open-WebUI. For me, it's installed on my machine, and you can activate it by having the Open-WebUI and then serve. It's going to take a fair bit of time. I've already activated it here. You can easily see it here when you click on Open-WebUI serve. You can go to the local host 8080 up top, and you will be greeted with a ChatGPT-like interface where you can have your own models here. If you have a number of the models downloaded by Ollama, you can also check the models by going to the admin tab and going to parameters and then going to models, and then you can download any model from Ollama through here as well. You can change the API if you have changed the API of Ollama as well. You can delete whatever model you see fit from here as well, and you can add lots of chat templates and a model file here so that the model behaves as you want. And we're going to be exploring this in a little bit more details at the end of this video. So in relation to the PyTorch and CUDA compiler compatibility, I've crafted these two short code blocks to understand what version you have, and in these two code blocks you have to have the same version. So here it's 12.4 and here as well it's 12.4. So now I'm making sure that I have sorted out the compatibility of PyTorch and the Nvidia CUDA compiler. The second part of this video is all about importing the necessary libraries and downloading the large language model of choice. The large language model of choice that we're going to be using today is the Llama 3.1, the Instruct from Meta, directly from the Meta's repository on the Hugging Face website. So I'm importing first Unsloth and the fast language model from Unsloth with all of the patching capabilities of the Unsloth, and then I'm defining some parameters. So here I'm starting with what sequence length, the more the merrier, but this is going to come at the expense of GPU. The same with the LoRA ranks. You can define inner ranks from 8 to 128 depending on what you need to achieve, and also that's going to be at the expense of the GPU. I am downloading the Meta Llama. I'm loading it in 4 bits. You can load in any quantization that you want. If you want to use the LoRA 16-bit precision, put it as false. And I'm also using 60% of the available memory. You can use all of your memory if you so prefer. That's going to be dependent on what you need to achieve. So the main goal of this step is to load the model itself and its tokenizer. And I am enabling the fast inference through VLLM. If you're using Windows, that's not an option, unfortunately, for the time being. So you have to use Linux if you want to use fast inferencing. If you're using Windows and you want to crack on with Unsloth under Windows, put it as false. I'm jumping to applying the PEFT, or the parameter efficient fine tuning, with the LoRA adapters themselves. You can choose whatever ranks that you want, as we said above, from 8 to 128, and you can state the projections themselves. And I'm using gray checkpointing for more efficient use of memory. And the result of that one is as follows. It detected my VRAM and it detected what is the capability. I think the compute capability has to be above 7 for Unsloth to work. And as you can see here for the utilization, it was loading VLLM loading of the Unsloth Meta with the bits and bytes for bit quantization, and the utilization of the CPU is at 56.7%. The third part of this video is about the data preparation and creating some functions for the reinforcement learning from human feedback for the purpose of fine-tuning of our downloaded model. The dataset that we're dealing with today is about the Royal Institution of Chartered Surveyors assessment of professional competence for those candidates who are interested to get chartered. I have put in some actual submissions and synthetic data as well for different areas of competence and different levels. A simple dataset that you can easily create from any PDF by using Python to convert it into JSON format or CSV format. Extraction of data into the form of 3 columns, the ID of the column itself or the row itself, the question and the answer. And what I'm doing here is I'm starting with creating a system prompt and some sort of format template that was advised by Unsloth, but I've added further explanation in my code. What was created is an XML format of the output, the code itself, to mimic a chain of thought with some sort of placeholders. The first thing that we need to have is a function for extraction of the answers from the model itself. We are extracting also the hashtags for formatting purposes, and then it's time to load the dataset itself as a CSV. So getting the data from the file that is specified, converting it into a pandas data frame, and then build a chat template for the questions and answers, and having a system prompt as well, which we have created above. And then building in some functions to reward the model for the correctness in getting the right answer. The first one is related to the correctness, giving the model 2 points for correct answers and 0 for incorrect answers. Moving towards the integer reward function, giving the model half a point for integer answers that are retrieved from the data itself and 0 otherwise. And then also taking care of the formats by including some regular expression patterns and searching, taking into account the reasoning part on the answer itself, given half a point for strict format match and 0 otherwise. And the last two functions here are count XML, where the model is being penalized or rewarded for following the same exact XML schema that we're using above for the reasoning and for the answer. Penalizing if the model is not closing the brackets or the smaller and larger sign after the answer or reasoning, and giving the model itself a reward for sticking to what we want it to do. And then the last piece of the puzzle here is scoring the completion using the function above. So using this function here, the count underscore XML, we're using it in the XML reward function. The fourth part of this video is all about training the model using the reinforcement learning from human feedback under the generalized reward parameterized optimization approach, which makes the best use of having multiple outcomes and objectives and having reward functions to score the model and train the model accordingly. We are targeting a number of parameters that we're going to be tweaking before we crack on with the training, taking into account the precision optimization, the batch size, having some parameters for training stability like gradient checkpointing and the weight decay itself, and manipulating our resources so that we are not running out of memory. And here I'm making the best use of VLLM, so make sure to put it as false if you're on Windows, because VLLM is unfortunately at the time being only supported on Linux. And we are specifying the weight decay and the warm-up ratio. I've basically used the default values provided by Unsloth, except for the number of generations. You can create more generations so that you can score the model, analyze the model for each and every single generation. But the more the merrier, but it's going to come at the cost of the GPU itself. Also for the maximum prompt length, you can increase it however you see fit. If you're going to be doing this for organization use, definitely you're going to need more than 2000, and also for the completion length as well. For the maximum number of steps, it depends on the data that you do possess. I have about 500 rows of data. An epoch, it goes to one cycle of training, so it's going to go through the 500 rows of data. In my case, I did 1000 steps, so it's about 2 epochs and change. And here for the save steps, I was saving a checkpoint every 1000 steps because I didn't really care if I have an electricity cut out or something like this. But if definitely you have more prominent training, you might need to save every 50 to 100 steps. And also the maximum gradient norm, I have kept the value to low in order not to have various values of the gradients. And I was calling all of them arguments that I did before and all of them reward functions. So first of all, I had to declare these two values because when I was running the code, I got an error that I have to declare these two values, being verbose about the code itself, and the torch logs to be dynamo. And for the GRPO trainer, that's where things are a little bit different from other bits and pieces because we have here the reward functions. So it's not just the tokenizer and the training arguments and the dataset, but also we need these reward functions to train the model back and forth. And then I'm implementing the trainer.train, and it took me about 2 hours and 15 minutes to complete the whole training. So it's more than the previous Unsloth method where we used the supervised trainer SFT, the GRPO, because it includes reasoning, it takes more time. And for the reward itself started with me at -2, but then scrolling down to the end, it was quite close to 1.5. I would say the results has been quite close to 1.5 since start of the 900 step. So probably I just needed 2 epochs instead of having 2 epochs and change. The reward itself, you might find different reward values. In the Unsloth notebook that was provided by the team, they said for the first 100 steps, the reward is 0. So be patient for the first 100 to 150 steps. And here is the first training step itself. It's not the greatest because it digressed a little bit from construction to IT systems. But that was the first step. In the Jupyter notebook that you can find on my GitHub repo, you will find the 1000 question and answers and how we tackled them from a reasoning perspective and from an answering perspective. Jump into the fifth part of this video, or the fifth step, which is all about testing the low rank adapters after we finish the training and merging the low rank adapters with the original model to be in one merged model, which can then be saved as safe tensors and converted to GGUF format, which is exactly what we're going to do in this step. So first off, I was checking the quality of the LoRA adapters after the training by asking a very simple question, giving a good quality example of procurement and tendering, and it was pretty decent. That it started with as a quantity surveyor. We do tendering and procurement for new office buildings with value and the tendering strategy. So it's pretty spot on. Market research, we need to do market research as well, and pre-qualification questionnaire, PQQ. So that is spot on. It's quite detailed and it's really trying to make the best use of thinking behind the scenes. But with the parameters, I've kept the temp chart to a minimum because I needed precise and concise responses as much as possible. I'm not really interested in being too much creative about this. I increased the maximum tokens to give the model the best chance possible to check if the LoRA adapters are really good or bad. And then I saved the LoRA adapters using the model.save_LoRA separately, and you'll be able to find the file here or the folder here which contains all of the LoRA adapters, the JSON file for the configuration, and the adapter.savetensors, which could be merged whether here or in any other code. And here I'm loading the LoRA after saving them. So I put in what prompt I want, what is the chat template itself in here, and I am getting the model.load which was saved here, because once I've saved the LoRA in here, as you could see on the left of the screen, I could load them in whichever merging mechanism that I want. I could load them and then I could test them, and then I could possibly merge them with the model of choice. I kept here the temp chart to be a minimum. Here I found very weird answers, although above it was good, but here it was not that great, which was a bit concerning. So I continued with the merging the LoRA with the base model, because in here, in the testing the fine-tuned model, when I was using the LoRA directly from the training, it was giving very good answers. But here, after I've saved the LoRA and then I loaded them, it was giving very weird answers. But I said I'm just going to give it the benefit of the doubt, and I'm going to merge it using the Unsloth method. So model.save_pretrained_merged, and I merged the LoRA with the original model, which is the Llama 8 billion parameter. The tokenizer is already defined in previous steps, and I merged them to be 16-bit because I'm going to be compressing them later on into 8-bit. Normally this is the final step of the code, but when I did the model save pre-trained _GGF using the Unsloth libraries, I found that there was an error, because normally you would be putting what is the name of the model that you have saved, which I have deleted it now, but I used to have it as a folder. Once you put that as a comma, the last argument will be the quantization method, which is Q8_0. When you don't put it here, by default it's Q8 quantization. When I ran the code, I found that there was a problem, and it says that the Llama.cpp doesn't have this Llama quantize anymore. Apparently the Llama.cpp original repository, it had some changes, and these changes, they were not reflected in the Unsloth method. And now I'm going to tell you how you can sort that out in the next part of this video. This part of the video is all about how we can use Llama.cpp to compile the LoRA adapters together with the original model, save them in one merged model as a 16-bit, and then quantization into 8-bit format using Llama.cpp and not relying solely on the connection between Llama.cpp and Unsloth under the Unsloth main library. So the way to do this, you can go to github.com/ggml/llama.cpp and you can click on the code here, get the code itself, go to your VS Code where you have opened all of them files and folders, go to terminal, new terminal, make sure that you are activating your own virtual environment through source and then the name of the environment itself, _env_march25, and then /bin/activate, and then you can git clone and then the link that you have copied and then press enter. For me, I have already cloned it here, so what you could do is cd, which is change directly, Llama.cpp, and then it's going to change the directory here, and then you can say pip install -r requirements to install all of the dependencies for Llama.cpp to work perfectly on your computer, and then press OK. I have everything installed from the requirements. And on a side note, I've also included within my GitHub repository the original Unsloth requirements, so that if things went wrong at your end during any time of the fine-tuning, you can go back and install the Unsloth requirements. Once you do that, you'll have everything now intact and you're going to be ready for what we're going to be doing now. So here I'm using the transformers package to read where the model is sat. So the model is sat in here. That's the model that is downloaded from the Hugging Face website. It's normally on the .cache under the name of the user, and then go to Hugging Face, hop, and then models, and you will find the name of the models that I downloaded from the GitHub repository. So I've defined here the base model path, and I've also defined where LoRA adapters are sat, and here I'm applying the LoRA to the base model so that they are basically merged and unloaded, and the output directory is in there. That's going to be 16-bit, and I'm saving the model and the tokenizer in this output directory. And once that's done, you will find that the merged model has been saved successfully in whichever place you want. And then here's the role of Llama.cpp. There's one of them files that is located on the Llama.cpp is conversion of Hugging Face models to GGUF format. And when you go to wherever the Llama.cpp is sat and type in the name of the Python file of conversion of Hugging Face to GGUF format and then --help, you will find all of them arguments. So for this file, we need to specify which model we want to convert to GGUF, what is the output file name .gguf, and also here what is the quantization method that we want, and here we're going to be using the Q8. We can also specify lots of them bits and pieces, such as being verbose, the no lazy, which is going to be needing more RAM. And as you can see here, I've carried out the conversion to GGUF format from the safetensors format. I've specified where the merged model is saved, and then what is the location and the name of the final file. And also I specified explicitly what is the quantization method that I want. I specified that I want to disable the lazy loading, which forces everything to be loaded out, and I want to list as much information as possible and having logs during the conversion process using the verbose method. And when I run that, that's the output that you should be seeing. And at the end, you will find that everything has been written, and that's the size of the file, which you can find here on the left side of the screen. That's the GGUF format converted file. And now moving to the last part of today's video, which is making the best use of the fine-tuned model on Ollama and also deploy it on Open WebUI. So Ollama, as explained before, it allows the chat with large language models locally, and you can embed them in loads of other applications using the Ollama's API. And Open WebUI is a web-based interface, and it resembles ChatGPT. It allows dealing with large language models locally on your machine through Ollama, and you can even use the Open WebUI pipelines to connect to other models on the web, such as OpenAI models or Anthropic models and loads of other models. In order to be able to use the fine-tuned model on Llama, we need to create something called a model file. Model files normally, they are composed of parameters and templates or some other bits and pieces that we're going to be discussing now. You can explicitly say what parameters you want to put, the temperature as well. You can explicitly say what is the chat template that you want the model to follow and to make the best use of, and also what is going to be the system prompt. And that's exactly what we're going to be doing here. You can also find on my GitHub repository the model file that I have created and we're going to be explaining in today's video. And now back to the code itself. So create the model file wherever you want. I've created it within the same folder where I have the GGUF file and I called it model_file. You can create it as a TXT file and then remove the TXT extension from it. So first of all, you have to state where the model is sat. So here I said from and then the location of the GGUF model. I have stated some parameters as well in terms of the temperature and also taking into account the chat template of Llama, where it has this kind of weird start header ID and end of token. Otherwise, the model is going to be generating responses endlessly. Also, you have to follow the chat template of Llama itself, which I have done here. I've copied and pasted that from Ollama. So starting from the template until the system prompt, I've copied that from Ollama's website. And here for the system prompt, I have dedicated more information related to the RSS APC. You can change that as you see fit. The model file is editable. You can edit it on VS Code or any text editor. I've stated explicitly that the model itself is specialized in quantity surveying and the drafting of summary of experiences for RSS APC candidates, and what are the guidelines that you have to be wary of during answering the questions. And the last piece of the puzzle here is go where the model file is saved and then open in terminal. As you can see here, it opened in the RSS, wherever it is, and then type in Llama, create, and then the name of the model that you want. Let's say we're going to call it RICS underscore APC underscore Llama underscore GRPO for argument's sake, and then -f and then model underscore file. And I've typed it model underscore file because that's the same name that I've put here. If you have changed that naming convention, change it here accordingly. Choose whichever name that you want and press on enter. That's going to create the model within Ollama. The model I've created, I can access it and see where it's at. So when I type in Ollama list, you will find the first one here, RCS APC Unsloth GRPO. I've created it a couple of days ago. It can be accessed from within Ollama run, and then I can copy the name of the model itself and then paste it here. And then it's going to take a bit of time to load the model into my GPU. And then I can ask it any question that I want. Give me a good quality example of procurement and tendering level 2, which is all about doing. Make sure to stick to my line of expertise as a QS in the UK. And then I'll press on enter, and as you could see, it's instantaneous in terms of the response itself. It shows the response quantity surveillance and the effective procurement is critical, some of the aspects as well. What is a practical example? Improvised rule, we used to stage tendering, and then reasoned advice and experience. That is way better than the previous fine-tuning using the classic fine-tuning on specific responses, which makes the model quite specialized but also quite dumb. It makes the model too focused on one specific area. And then if you want to continue the conversation, it's up to you, and you can close it using /by. Once you have created the model on Ollama, it's now accessible on Open WebUI. Go here and then you can choose whichever model that you want, and I've done the same exact thing with it. I said could give me a good quality example of procurement and tendering level 2, and it began giving a very good answer, taking into account also the formatting as well. And here I said tell me what to write in my RSS submission, and it's spit out very good responses, as well as taking into account the case studies, which I did not even include in my training data. And then I said what to specifically write. It evaded answering correctly in that question, which was a bit odd because I said tell me what to write. That is not what I'm going to be writing in the submission, but it wrote here something that is really good, which is example from my experience. And if you are drafting your submission, you can make the best use of the ideas that it tells you here to enhance your response. So you can actually build on that one by making the best use of these lines here. And that's all about it really. That's how you can download whichever model that you want from the Hugging Face website, get the data, transform the data in the way you see fit, have their reward functions as well, and then train on the GRPO under the reinforced learning from human feedback to get LoRA adapters, which can be merged with the original model under one merged model, which can then be turned into a GGUF file that can be used on a wide variety of them interfaces. Thanks a lot for watching. Hope you found this video useful and insightful. I've prepared a couple of them other videos about fine-tuning large language models and deploying them to Open WebUI. I'm going to be putting the links in the description below. You can also pay my website a visit at www.apcmasterypath.co.uk, where I provide multiple packages for the RICS APC candidates to support them throughout their RICS journey. Also, I provide lots of insights about the RICS APC process, the different areas of competence, and how you can deploy AI within the construction industry. Do not forget to hit the like button and subscribe so that you get notified about our latest videos.